All right, let's dive right into this explainer and, really demystify that invisible neighborhood connecting all of our screens. Because look, we all know data isn't just magically floating through the air on fairy dust, right? There is a very real, very concrete routing system running the whole show behind the scenes. So today, we're going to break down that architecture and look at the actual nuts and bolts mechanics of how our devices communicate. Seriously, though, how do your devices actually talk to each other? I mean, it's so easy to take for granted just how seamlessly your phone, your laptop, and that smart TV in the living room share information. But beneath those slick, polished interfaces, how on earth does a tiny packet of data find its exact destination without just getting totally lost in the noise? Well, that logical transit system is exactly what we're focusing on today. So, part one, what is a network? Let's lay down that core foundation. At its absolute core, a network is beautifully simple. It's really just a group of devices linked up for the sole purpose of sharing data. That's it. Whether we're talking about two local nodes just sharing a printer or massive server farms spanning the entire globe, a network exists literally just to get endpoints talking to each other. It is the absolute bedrock requirement for all modern computing. Moving on to section two, the neighborhood analogy, or mapping out our digital worlds. Now, a super effective way to actually picture this architecture is by using a physical neighborhood metaphor. Think of it like this. Every single device you own is a house. The Wi-Fi signals and those physical cables, those are your roads. The data packets are the letters speeding through the mail. And your router? Well, your router is the local post office, making all those critical split-second dispatch decisions. Framing it this way makes all that invisible traffic suddenly feel incredibly real and tangible. But here's the catch. For that local post office to actually do its job, it needs exact locations, right? So every device gets a unique IP address, something like 192.168.1.2. And you should think of this exactly like your physical house number. This unique identifier guarantees the router knows precisely where to drop off those incoming packets so they hit the right endpoint every single time. It completely removes the guesswork from the equation. All right, section three, local versus wide area networks, and how we scale this whole thing up. As we scale up, we're basically looking at two main environments. First, you've got your LAN, or local area network. This is that cozy, private, super high-speed bubble in your home or office. It handles all your immediate local traffic. But what happens when a LAN in New York needs to talk to a LAN in Tokyo? That is where the WAN, or wide area network, comes in. It's the massive infrastructure linking up those totally separate geographic locations across huge, long-distance transit lines. And if we zoom all the way out, it's honestly kind of mind-blowing to realize that the internet itself operates on this exact same principle. The entire global internet is literally just the world's biggest WAN. It's this ultimate planet-sized wide area network connecting millions of those little local neighborhoods together through massive digital highways. It really is just networks connected to other networks, all the way down. Now, bridging that gap between the local and the global safely, that requires a gateway, and that is exactly where our hero, the router, sits. It's got one foot in each world, right? One side manages all the local devices safely inside your private network, while the outward-facing side handles the crazy complexity of routing your traffic onto the massive public internet. It's the ultimate translator, turning your cozy neighborhood requests into wide-area global communications. Which brings us to section four, why this foundation actually matters for building the rest of the framework. Getting a solid grip on this basic topology is absolutely crucial because literally everything advanced in IT builds right on top of it. Things like network switches, VLANs, and firewalls, sure, they add some complex layers, but at the end of the day, they just exist to dictate how traffic moves around this exact framework we just talked about. They're just the advanced traffic lights, the zoned commercial districts, and the security checkpoints for your digital neighborhood, keeping the flow smooth and enforcing the rules. So think about all those data packets leaving your local network right this very second. You understand the map now, you know the gateways, and you know the routes. But who is actually intercepting, directing, or maybe even monitoring those delivery trucks once they roll out of your safe, secure land? Well, we are going to leave you with that provocative little thought about network security to ponder until our next explainer. Thanks so much for joining us.